All right, this video is on electrolytes. So, an electrolyte is a substance whose ions dissociate. So, what that means is the ions will separate into positive and negative, and we will know this because an electrolyte will conduct electricity. So, for example, in this beaker here, if I have a solution and the solute is an electrolyte, and I put a light bulb and a battery and I hook it up to it with wires, the electrons will flow through the solution. Okay, and we'll look at this and talk about this in class as well. So what kinds of things are electrolytes? Electrolytes are two different substances you should know about. So ionic compounds and acids. Ionic compounds, if you remember, is when we have a metal and a nonmetal. The metal becomes a cation, positive, and the nonmetal becomes an anion, which is negative. And the key to this is it has to be ionic and it has to be in water. If you have an ionic compound as a solid, but it's not dissolved in water, it will not do this. So when an ionic solid dissolves in water, the ions dissociate. Or another word for that simply is just they separate. So for example, okay, if this is my solution, all right, and let's say my solvent is water, I'm going to have a whole bunch of H2O molecules hanging out in here. Okay, so here's some H2O. Here's some more. All right, there's a whole bunch. They're all over. I'm not going to draw that many more. Now, let's say the solute is, let's see, what's one we wrote up here? KBr. KBr is ionic because it is a metal and a nonmetal. Potassium, K being the metal, makes a positive ion. Bromine being the nonmetal makes a negative ion. So when you actually put the KBr in this water, you get a whole bunch of Ks all over by themselves as ions. And then you have an equal amount, because there's one K for every one bromine, you have an equal amount of bromines hanging out in here as well. And because you have this positive negative going on in here, if you add, like I talked about, like that wire, all right, and let's say we have a battery right here. Pretend this is a really good drawing of a battery with a positive and a negative. You've got this hooked up to here and this one, and let's put in like a light bulb. All right, and it's hooked up to this other side. Oh no. All right, you're gonna see this light bulb will light up and electricity will flow the electrons through here from wire to wire because we have positive and negative. So that's an electrolyte. So ionic compounds will always be electrolytes. And we write this dissociation equation like this. We show the KBr when it's aqueous. Remember the AQ? So that's telling us we have the solute is KBr, the solvent is water, and it dissociates, so it separates into K+1 ions. They're also aqueous, right? They're still in that water. And we've got bromine ions, also aqueous. Okay, so something like Na3PO4, sodium is the metal. Kind of scooch down here, right? Sodium becomes a +1. It's aqueous, but notice there's 3 of them. So there's 3 sodiums for every 1 phosphate ion. It's a -3. But these would also conduct electricity. So other things that are electrolytes that would conduct electricity are acids. Now, acids are compounds that contain hydrogen with an anion. So not just any compound with hydrogen. It's got to be hydrogen is the cation, the positive, with some anion like bromine, chlorine, or a polyatomic ion like phosphate or nitrate. All right. When that happens, they will dissociate just like ionic compounds. So here we've got HCl, that's an acid because we have hydrogen with a +1 charge. And we've got chlorine with a -1. H2SO4, same kind of thing, but we have 2 H pluses. And then we've got 1 sulfate. So notice our equations are still balanced, just like we did in the past. Okay. All right. So non-electrolytes, okay, obviously, I think this is obvious, substances that do not dissociate. So they're not separating into ions. So there's not conducting electricity. So in this container, let's say we've got our water still as our solute. So it's still a solution. Solvent. So let's say water is still our solvent. So in here, we've got all our H2Os again. Okay, and our solute is a molecular compound like sugar, and there's all different kinds of sugar, but they pretty much are all molecular. I'm going to put a bunch of little S's in here for sugar. They hang out. Notice I'm not writing a charge because there aren't any. They're together, all of the atoms in there, and there is no charge difference. So I hook up that whole battery light bulb situation again, and nothing's going to happen. No electricity will flow because we don't have this positive and negative to go through. So molecular compounds are molecules that do not dissociate. So if you remember, molecular are not ionic, so it's typically going to be multiple nonmetals. So these are going to be things like I said, sugars. So sugars are things like glucose, fructose. They all end in kind of ose, sucrose. And they all have these formulas like glucose and fructose actually have the same formula, C6H12O6. Sucrose is C12H22O11. They all have kind of this same CHO formula. Notice they have H, but they are not acids because the C and the O are not an anion. All right, other things that are also molecular are hydrocarbons. We talked about these when we talked about combustion. So remember, these are things that have carbon, hydrocarbon, and hydrogen in some formats, right? Like, for example, we talked about methane. That was CH4. Or we can talk about ethane. There's a whole bunch of them. All right. And then lastly, another one we also talked about were alcohols. And alcohols were like hydrocarbons that had a hydroxide on them. So these would be things like methanol, which is you drop an H from that CH4 and you put an OH on it instead like this. Okay. And we will go through more examples in class, but these are electrolytes and non-electrolytes.